Hi everyone, we're going to start class notes on 8.2, which are rational exponents, and these class notes will be taken on April 1st. Happy April Fool's Day. Really miss seeing you guys, and we will get started. You will need to have your power sheet. It will definitely help. We're actually going to use it backwards when we have a root, and then when we need to take to a power, we'll use this column. So we're going to use this in two ways here. But the most important part is knowing that every root, because you're used to roots, you're not used to fractional exponents, but you're used to roots. So every root, a root has an exponent. If we wanted to raise it to the power instead of using a root, it has a fractional exponent. So anytime you see a fractional exponent, it represents a root. It represents a radical. Any fraction for an exponent, you can write it as a root and deal with it that way. So I prefer to write it in radical notation and then just work to simplify. This is called rational because it is a fraction, right? Rational means fraction. Fraction as an exponent represents a root. We're more comfortable with roots, so I like to, if I see a fraction exponent, write it as a root and then simplify. The bottom number in the fraction tells you your index, tells you what root you're dealing with. Square roots, cube roots, fourth roots, things we've talked about already in class. So really you just got to remember bottom number in the fraction is the root. The top number is the power that you're raising it to. So x is to the first there. And here, this would be the nth root. We don't know what the, my computer. The nth root is, and then the exponent would be an m. So I like to do the root first because that makes the number smaller, and then when we raise it to a power, it makes it a bigger number. So it's easier for us because we're not using calculator to do the root piece first and then the power. Okay, let's go ahead and start examples. I'm going to leave power sheet here, and then if we need to refer back, we can. Most important is remembering the bottom number in the fraction is the root that we're dealing with. The top number is the exponent, and we'll do that piece last. All right, moving on to examples. So, first example, this tells me I have a cube root, right? An exponent of 1 cube root. So I'm going to rewrite it as the cube root of negative 64, and then I can worry about the 1 after. So can we have a negative under a cube root? The answer is yes, because a negative times a negative times a negative is a negative. That's the reason we can. I go to my power sheet, I go to my cubes, I look for 64, and I know that the cube root of 64 is 4. And in this case, it's going to be negative 4. Now the power is just 1, so negative 4 to the first is still going to be negative 4. Second example, the 4 tells us the root, the 1 tells us the exponent. So this is a fourth root problem, fourth root of negative 81. Now can we have a negative under a fourth root? The answer is no. There's no value here. You can't have a negative under an even index. You can have a negative under an odd index because, again, a negative times a negative times a negative times a negative, 4 of them would become positive, and that would never be negative. I think I wrote this one wrong. I want to do this one without parentheses because otherwise it's the same. So I'm going to erase my parentheses that I have here. And I want to think of this as 81 as being raised to the 1/4. Again, what does the bottom number tell you? It tells you what root you're dealing with. What does the top number tell you? The exponent. The negative piece, because it's not in parentheses, the negative hangs outside. Then I'm dealing with the fourth root of 81. So now I'll go to my perfect fourths, find 81. The fourth root of 81 is 3. I have a negative outside, so this becomes a negative 3. Again, top number is a 1. Raising to the first power is just going to be negative 3. So here I have 1/3. I like to think of this as my parentheses in my exponent rules. Remember, exponents rules say take the exponent outside, multiply with your exponents inside. So I recognize this represents the cube root, and then just to the first power. Cube root of both of these, the cube root of 1 and the cube root of 27. Go to my perfect cubes. Cube root of 1 is 1, cube root of 27 is 3. This becomes 1/3. What power do I have to raise it to? 1, and 1 to the first and 3 to the first stay the way they are. Okay, now we're going to deal with a top number that's not a 1. But again, bottom number tells us the root, so let's take care of the root first. Cube root of 27. Cube root of 27 is 3. And then we need to do the top piece, which is square it. And 3 squared is 9. Final answer is 9. Negative, not in parentheses, negative stays on the outside. Bottom number is 2. That means we're dealing with the square root of 16. Top number tells us exponent. We're going to wait after we evaluate the root piece first. So square root of 16, we should know, my paper's folded over, that that's 4. So I get negative 4. And then I have to cube that negative 4. Base is negative. I'm going to put it in parentheses to raise it to the power. Now 4 cubed is 64. Negative 64 because 3 of them would be negative times negative times negative. Final answer for that one. Negatives in the parentheses, so I need to take the cube root of negative 64. Why the cube root? Because that's the number that's in the bottom. 64, cube root of 64 is 4. Again, because of the negative, it's a negative 4. And then I have to raise it to the power of 2. And a negative 4 squared becomes a positive 16. Final answer there. Negative exponent, remember we can't really deal with negative exponents until we make them positive. So negative exponent means we need to write it with a positive. We have to move this whole thing. Remember, we make a move from numerator to denominator, the exponent becomes positive. So now I just deal with a 1 over, again, what does the 4 tell us? The root. And the top number, the cube piece, or the 3, will tell us the exponent. But first, we're going to take the root. The 4th root of 81. Go to your perfect fourths. 81 across from it, 3. So I have 1 over 3, and now I need to cube that because I still have to do the top piece. 3 cubed. Go to my perfect cubes. 3 cubed, 27. 1 over 27. Final answer there. Another negative exponent. There's a shortcut here. Remember, if you have a fraction and you have a negative exponent, you can flip the numerator and denominator. And the exponent outside now becomes positive. Or you can multiply and then, again, move from top to bottom and you will get the same thing. So what is this saying? What root is it saying? It's saying square root. So the first thing I'm going to focus on is taking the square root of both of these. Then once I'm done with that, I'm going to focus on doing the top number, which is my exponent. So then I'll have to cube everything. But first, seeing this, I know I need to take the square root of 25 and the square root of 64. 5/8, and then I need to cube. Why am I adding that piece in? Again, because my top number in the fractional exponent tells you what power we need to raise it to. 5 cubed. 5 cubed is 125, and 8 cubed is 512. So 125 over 512. 125 over 512. Final answer. Okay, that is it for today. Please let me know if you have questions. Bye, everyone.